Hello, welcome to another SRv6 demonstration. This time we will show, together with Hui, how Unreachable Prefix Announcement works. The very important concept of SRv6 network is summarization. Summarization provides two benefits for SRv6 networks. It allows practically infinite scalability while preserving ultimate SRv6 simplicity. Summarization is done always on domain boundaries, but the summary route, in fact, hides what is happening in the remote domain. So basically, information about egress PE failure is hidden from all devices in the local domain. And if ingress PE does not see the failure of egress PE, it cannot trigger some fast convergence technologies like BGP-PIC. BGP-PIC, prefix independent convergence, essentially allows sub-second convergence in case of egress PE failure. The main trick is that ingress PE very quickly switches to a set of the pre-programmed backup path as soon as it receives information about egress PE failure. Therefore, it does not have to rely on BGP convergence itself, which is naturally very slow. So the main question here is how to trigger BGP-PIC while remote PE failure is hidden in the summary route. The answer is UPA. Unreachable Prefix Announcement. In our demonstration network, we have two ISIS domains. It is not really important whether these domains are part of a single ISIS process, like levels, or totally two independent different ISIS processes. On the left-hand side, we have ingress PE, and on the right-hand side, we have two redundant egress PEs. Domains are connected by the ABR router, which is responsible for the propagation of locators between domains. Here we can see locators of both egress PE routers. There is a single CE connected to both egress PEs and IXIA traffic generator, which advertises 800,000 prefixes full internet table towards CE router. Both PEs are advertising these prefixes via route reflector in VPN v4 address family towards ingress PE. For all prefixes, we set PE11 as primary and PE12 as backup using local preference. And same IXIA feeds 800,000 streams of traffic to ingress PE. IXIA will be used to measure convergence times in case of failure. Obviously, there are few more routers in each domain, but these are not important for our demonstration. Here is a terminal window for all important routers for the demonstration. This is PE1, so ingress PE, and because we are not doing any summarization yet, ingress PE should see both locators in the routing table exactly as they are advertised, so /48. Because no summarization is configured, BGP-PIC can work normally. But this is obviously not the point of this demonstration. So we will configure the summary route /40 on ABR to be sent into domain 1. So we will configure ABR router and summary route into the process. We can immediately verify ingress PE, and now we can see ingress PE does not see individual locators as /48, but see just one single summary route for both of them. Now there is a time to simulate egress PE failure. So we will shut down core facing interface on PE11. Remember that PE11 is primary for all prefixes. Commit. Now, because there is no possibility of any detection of PE11 failure on ingress PE, we have to rely on BGP convergence. route reflector has to detect a BGP session failure, and as soon as session failure is detected, route reflector has to withdraw all 800,000 prefixes from BGP. And ingress PE can reprogram whole forwarding table. Let's take a look at Ixia. We see there is an outage, and as soon as egress PE fails, we lost all streams. Then some time is needed for the route reflector to detect BGP failure and then withdraw all prefixes one by one, and PE1 has to reprogram whole FIP. Here we can see that overall outage was 52 seconds. Let me reset counters here for the next measurement. Naturally, even in very large SRv6 microSID networks, we need sub-second convergence. And sub-second convergence can be achieved using UPA, Unreachable Prefix Announcement. How it works? In a stable state, ABR is advertising summary route only. But when egress PE fails and ABR sees that connectivity to PE11 was lost in their command domain, then immediately advertises the UPA prefix. UPA prefix is a more specific prefix, but with specific metric, which means unreachable. That update is received by ingress PE, and ingress PE can trigger BGP pick. Very important is that the UPA route does not need any extension of IGP protocol. It is just regular update with so-called unreachable metric. We need to configure ABR to generate UPA for a specific summary. And also we have to configure ingress PE to react on UPA route and trigger BGP pick. Before egress PE failure simulation, let's verify that PE1 still sees only summary route. And again, we need to shut down egress PE core facing interface to simulate failure. And let's check the length of the outage on Ixia. Here we can see outage was very short and precisely 351 milliseconds, because ingress PE was able to trigger BGP pick thanks to UPA prefix advertisement, which we can see in ISIS database here with an unreachable metric. So just to recap what happened. Once PE11 failed and such information reached ABR in domain 2, at that particular moment ABR generated next to the original summary a more specific UPA route with an unreachable metric. That information was flooded into domain 1, and as soon as that information reached PE1 triggered a very fast switchover in forwarding table to all backup path available. No BGP involvement in immediate convergence, and UPA route is in ISIS always just for a limited predefined time period, and once full convergence of BGP happens, UPA route is removed. In summary, we demonstrated UPA, Unreachable Prefix Announcement. This technology enables BGP pick in very large SRv6 microSID networks. We demonstrated sub-second convergence for 800,000 prefixes. UPA doesn't need any specific new protocol extension. UPA doesn't need any specific software or configuration on any intermediate nodes. It is enabled only on ABR and PE routers. That's it. Thank you for your time, and also thanks all contributors to this demonstration. If you want to know more about the latest segment routing technologies, follow us on social media. Our best source of information is always segment-routing.net. Goodbye.